at the first, there's two interest formulas, and it all depends upon how often the financial institution is actually calculating interest. So when interest is due at the end of a payment period, it's added to the principal. Principal, remember, is your initial deposit, or it's your balance. So that the interest computed at the end of the next period is based on the new principal amount. This is what we call compounding interest. You may have heard the phrase, your money earns money, and that's what's happening. If the bank pays you interest and you don't touch any money in that account, the bank will start paying interest on that interest that's already deposited. That's that phrase where your money starts making money for you. This is your compound interest formula. So let's talk about the different pieces. This P is your initial deposit. So if you take $100 and you deposit into your account, that would be, and open up an account, that would be your P value. N is the number of times interest is compounded. R is your interest rate. And again, when you're using these formulas, you want to make sure you convert this into a decimal if needed. We already talked about N, and T is time. If I want to know what the balance in this account will be after 5 years, then I would plug in 5 for T. A is when you're calculating for A, it's your amount after T years. So if I want to know how much is in the account after 5 years, that is what my A of T would be. So some common N values that most financial institutions use. When they say they're going to compound interest annually, that means they're only going to calculate interest one time a year. So N would be equal to 1. Some financial institutions may say they're calculating interest semi-annually. Guess what N would be? N would be 2. Quarterly, 4. Monthly would be 12. And then daily would be 365. They have to tell you how many times they're going to be calculating the interest. Quarterly, semi-annually, etc. Now, some financial institutions do what's called continuously compounding. If it's continuously compounding, that means that it's continuously, every day, every second, it's calculating the interest. Granted, it's not depositing a whole lot in the account every day, but again, this has a different formula. I call this the PERT formula. P is the same as what we just saw. That's your initial deposit. That's your initial amount. E is our little e. R is our interest rate. T is time. So if they say it's continuously compounding, you use the PERT formula. Any other time it's compounding in a different time period, you would use that P times the 1 plus R over N raised to the NT power. So again, just to review the variables that are in both formulas. A is the amount after T years. P is our initial deposit. R is your interest rate. Remember, we expressed this as a decimal. So you have to convert, because the interest rates are typically given to you in percentages, so you have to convert those into decimals. And just to review, how do I convert 9% into a decimal? Which way do I move my decimal points? To the left or to the right? To the left. How many places am I going to move it? 2. So remember, this is equivalent to 0.09 as a decimal. Remember, you move it 2 decimal places to the left. T is time. E, again, is our natural number. And remember, it's about 2.71 ... You have an E button on the calculator that you'll use. You won't round it to 2.71. You'll use the E button on your calculators. So now let's go ahead and find the amount that result from each investment. So always identify your variables. So we're taking $50, we're investing $50. So which variable do you think the $50 is going to represent? That's going to be our P. 6% compounded monthly. So my interest rate is 6%, which as a decimal is 0.06. When I'm compounded monthly, what's my N value going to be? N will be equal to what? 12. And then T is going to be equal to what? I want to know how much is in this account after how many? 3. So then I have to use my first formula because the only time you use PERT is when they say it's continuously compounding. So again, my A is going to be equal to 50 times 1 plus my interest rate of 0.06 divided by 12 raised to the 12 times 3 power. Since we're dealing with money, how many decimal places should I round? 2. So we're always round it to the nearest set. So then here we go. We have 50, and again, parentheses. 1 plus, again, you can use the fraction bar, which is located under alpha, y equals, if you want, 0.06 divided by 12, raised to the 12 times 3, or just 36. So after 3 years, my $50 will have grown to about $59.83. Okay? So any questions on how I use that particular formula? So now you guys go ahead and try part B for me. Same formula, but what's N going to be equal to? N, since I'm compounded daily, what's N going to be equal to? 365. P, remember, is going to be your 700. R is going to be 0.06. T is going to be equal to 2. So hopefully you guys ended up with $789.24. So any questions on using that interest formula when you're compounding at certain times throughout the year? All right, so those are pretty much as straightforward problems as they could ask. So let's take a look at another one. So investment is made in a trust fund at an annual percentage rate of 9.5% compounded quarterly. How long will it take for the investment to double in value? They're not giving us, again, because I'm compounded quarterly, I know that it's going to apply this formula, P times 1 plus R over N raised to the N times T power. So I know for part A I have to use that particular formula. But what piece are they not giving you? They're not giving you the what? The initial value. They're not giving you the initial amount. But we want to know how long. So what does they want us to solve for? We want to solve for which variable in the formula? We want to solve for what? T. And we want to know how long it's going to take for my investment to double in value. Well, if my investment is P, what's double P? I could write that as what? 2P. So what I'm going to do is just take this equation and set it equal to 2P. So P times 1 plus. Again, they're giving me my interest rate of 9.5%. What is the R value then going to be equivalent to as a decimal? 9.5% will be equivalent to what? Point what? 0.095. So 0.095 divided by compounded quarterly, so what's N going to be equal to? N will be equal to what? 4. Over 4 raised to the 4 times T power. Yep.
I'm a little bit confused where the 1 plus comes from.
That's the formula.
Is that the E?
No, this formula right here.
Oh, okay. I was looking at the...
Yeah, the only time you use the second formula is if it says it's continuously compounding. Now the question is, I've got to solve for t. Well, what can I divide both sides of this equation by right away? I can divide both sides by a what? P. So then 2 is going to be equal to 1 plus 0.095 divided by 4 raised to the 4t power. Yes?
How can you just in the beginning, how did you get 2p?
Because it wants to, remember, I don't know what p is, they're not telling you. But we do want to know how long it's going to take to double in value. So I know that if my initial amount, let's say, is $50, if I double $50, that would turn it into what? 100. So to double something, I'm just taking that amount and I'm multiplying by 2. Any thoughts now how I'm going to have to solve this for t? Guess what I'm going to have to do to both sides of this equation? I'm going to have to take the natural log. The only way you can get this exponent that is a variable out is you're going to have to take the natural log of both sides of this equation. So I've got to take the natural log of 2 is equal to the natural log of 1 plus 0.095 over 4 raised to the 4t power. Anytime you are trying to solve for an exponent, you're going to end up taking the log of both sides of the equation. Now, the reason why we did that is because now what can I do with this 4t? I can pull it out of the exponent. So I have the natural log of 2 is equal to 4t times 1 plus 0.095 all over 4. So now I've got to get t by itself. T is being multiplied by 4 and multiplied by this whole entire ugly set of parentheses. So how do I break up multiplication to solve an equation? What am I going to do to both sides of this equation? I'm going to divide. So I know that the natural log of 2 divided by, and you can do this all in one step, divide by 4 and divide by 1 plus 0.095 all over 4. And that's equal to t. Again, anytime you have to solve for an exponent when you're dealing with these application problems, you're going to end up taking the log of both sides of the equation. All right? So now I'm just going to type this in my calculator. So I have the natural log of 2 divided by, and again, if you want to use that fraction bar, go ahead. That way you don't have to worry about using those parentheses. So natural log of 2 divided by 4, parentheses, 1 plus 0.095 divided by 4. Oh, I forgot this natural log here. Should be natural log. Sorry. Because it's natural log. I forgot about that natural log. I forgot to write the natural log here. I'm sorry. So it should be, I thought that didn't look right, natural log of 2 divided by 4 times the natural log of my parentheses 1 plus 0.095 divided by 4. 7.38. So about 7.383 years. So that's how long it's going to take for that investment to double. All right, so any questions on how you solve for t? Yes, Emmy? Natural log, yeah. Yeah. Yeah, and this is how you typed it in the calculator right there, if you want to check how I typed it in. Okay. So now let's take a look at B. How long will the investment take to double in value if it's continuously compounding? So if I'm continuously compounding, which formula am I going to use? I'm no longer going to use this P times 1 plus R over N. I'm going to have to use my PERT formula. Anytime they say continuously compounding, you're going to use PERT. Again, I still want to know how long it's going to take for investment to double. So I'm going to take 2P, set it equal to P times E. Still the same interest rate, 0.095 times T. So what's going to be my first step? Divide out the P. So 2 is equal to E to the 0.095 T. Now what am I going to have to do to solve for T? What do I need to do to both sides of the equation? I'm going to have to take the what? I have to take the what? natural log. So natural log of 2 is equal to the natural log of e to the 0.095t. Use your power property of logs. I can take the 0.095t and get it out of the exponent. So natural log of 2 is equal to 0.095t times the natural log of e. Remind me again, what is the natural log of e equal to? Natural log of e is just 1. So now what am I going to do to get t by itself? I'm going to do what? Divide by what? Divide by 0.095. So now I can type this in. So I've got the natural log of 2. Yep.
Shouldn't the 0.095 be 0.95?
No, because it's 9.5% interest rate. So when you convert that into a decimal, remember you've got to move it over 2 decimal places.
Yeah.
So 0.095. So about 7.296 years. So as you can see, your investment will double if it's continuously compounding a little bit quicker versus than if the bank compounds it quarterly. So your best bet is to find an institution that does the continuously compounding. Your money will grow faster. All right? Not a lot, but every little bit helps. All right? So any questions on that one? So here's number 3. So you have an investment of $10,000, and again, it's continuously compounding. So again, if I'm continuously compounding, what formula am I going to use? I'm going to use my PERT. So always know, guys, what formula is going to be applicable to the problem before you get started. Anytime it says continuously compounding, it's PERT. What annual percentage rate will produce a balance of $25,000 in 10 years? So what am I solving for in my PERT formula? Which variable am I solving for? R. So I need to find R. What is my initial investment? What is my p-value going to be? 10,000. What's my t-value going to be? 10. And then A of 10 is equal to $25,000. So I want to know, I'm going to take this formula and set it equal to $25,000. Equals 10,000 times E raised to the 10R. So what's going to be the first step here to start solving for R? I'm going to do what to both sides? Divide by 10,000. So I end up with 25 over 10 is equal to E to the 10R. Or I can reduce 25 over 10 to 5/2. R is in the exponent. So what am I going to have to do to both sides of this equation? I'm going to have to do what? Take the what? Natural log. So now again, I can use the property of exponents. I can get the 10R out of the exponent. So I have the natural log of 5/2 is equal to 10R times the natural log of E. And remind me again, what is the natural log of E? The natural log of E is what? 1. So then to solve for R, what am I going to do? I'm going to divide by 10. So then natural log of 5/2 and divided by 10. So it gives me this decimal of 0.0916. It wants a percentage rate. So now how can I convert that decimal into a percent? What is 0.0916 equivalent to as a percent? 9.16%. Okay? So any questions on that particular problem? So sometimes there's variations. You're not just going to be finding the amount. You've got to solve for the different pieces. Here's another question. John will require $4,000 in 2 years to pay off a loan that has no prepayment privileges. If he has $5,000 now, how much of it should he save in an account paying 5% compounded monthly so that in 2 years he will have exactly $4,000? Well, they're telling me I'm compounding monthly. Am I going to be using my PERT formula? No. So always identify the formula that's going to be applicable. It all goes down to what the compounding is going to be. So P times 1 plus R over N raised to the N times T. So let's see what they're telling me. What's my interest rate? My interest rate is what? What's my interest rate in the problem? 0.05 or 5%. So 5% as a decimal, remember, is 0.05. He needs to have $4,000 in 2 years. So what's my T going to be equal to? T is going to be equal to what? 2. In 2 years, he wants to have exactly $4,000. He's trying to decide how much to put away right now, how much to put away in the account. A lot of banks don't want you paying loans off early. And that's what this no prepayment privileges means. How come banks don't want you paying loans off early? I mean, he's got the money now. How come a bank doesn't want you to pay their, you would think the bank would want their money back? The interest. So either being charged interest. So if you pay a loan off early, you're going to cost the bank money because the bank's not collecting that interest from you. Because when you get a car loan or a house loan, you've got to pay interest every month when you make a payment. So if you pay something off early, you're actually costing that bank a lot of money. So that's why they say you can't pay these loans off early. All right? So in 4 years, that's my 2 years, I want to have exactly $4,000. So he basically wants to take the $5,000, figure out how much of this $5,000 I can put away right now. That way in 2 years I know I have all the money to pay off this loan. So we're trying to find P. He's trying to find out how much to invest right now. So any questions on how I've identified the different variables? So now let me plug them in. So 4,000 is equal to P times 1 plus my interest rate, which is 0.05. Compounded monthly, so what's my N value going to be? N is equal to 12, raised to the 12 times 2. Now remember, P is being multiplied by this whole entire set of parentheses. So how can I get P by itself? What can I do to both sides of this equation? Just simply divide by this whole entire set of parentheses. So then P is going to be equal to 4,000 divided by this whole entire set of parentheses. The 1 plus 0.05 over 12, all raised to the 24 power, or you can leave it as 12 times 2. So I type this in. Again, that fraction bar, guys, under alpha y equals option 1. So you don't make a mistake with parentheses. Maybe your friend when you're dealing with these. 4,000 divided by parentheses 1 plus 0.05 divided by 12, all raised to the 24 power. Oh, hell, if I raise that to the exponent. Hold on, I typed it in wrong. There. So I'm going to have to put away $3,620.10. All right. So any questions on how you can solve for P? Okay. Jane has just inherited a diamond ring. So not only can you use these formulas for money, you can use them for other items that have value. So Jane just inherited a diamond ring appraised at $7,000. That means right now the ring is worth $7,000. If the diamonds have appreciated in value at an annual rate of 8%, what was the value of the ring 20 years ago when it was purchased? Now, annual rate. So most items when we talk about appreciation or cars with a depreciation, it's just an annual rate versus a monthly, quarterly, etc. So it's an annual rate, N is just equal to 1. It's not continuously compounding, so I have to use my formula. A is equal to P times 1 plus R over N raised to the N times T power. So right now, the ring is worth $7,000. So that's the amount that the ring is worth at this present moment. I'm trying to figure out, well, how much was this ring worth 20 years ago? So I want to find P. Is everybody okay on why we're trying to solve for P? So what would T be equal to? T would be equal to what? 20. So I plug it in, 7,000 is equal to P times 1 plus, and again, the interest rate is 8%, so as a decimal, that's 0.08. Again, N is 1, raised to the 20 times 1 power. So again, to solve for P, I'm going to take 7,000 and divide it by this 1 plus 0.08 raised to the 20th power. So this ring was worth $1,501.84 20 years ago. You probably have heard before that it costs money to die, because what happens, this is what's called inheritance tax. So people that inherit things, the tax man's going to want their share of the money. So if a ring was purchased 20 years ago and you don't know what it was purchased for, then this is what happens. You've got to pay interest on the difference between what it's worth now versus what was paid on it 20 years ago. So inheritance tax is when you inherit something, somebody bought it 20 years ago for this amount, now it's worth $7,000, you've got to pay a tax on the difference between the $7,000 and the $1,500. That's why they say it costs money to die. So that's what the inheritance tax is. So that's why people have to know how much things were purchased 20 years ago. All right? Yes, Emmy.
I just want to make sure I get this right, in case it's on my test question tomorrow. 7,008 is 20 years.
Right. Because that's what the ring is worth now. We're trying to figure out what it was worth actually 20 years ago. All right? So sometimes they may give you a different formula. So again, we're investing $5,000 that's increasing at a rate of 4.25% a year. Then the value of the stock is given by a function. So they're giving us a completely different function, not one of the interest formulas. Assuming that the value of the stock continues to grow at this exponential rate, how much will your investment be worth in 4 years? So what do you think I'm going to plug in for X into this formula? I'm simply going to plug in a what? So X is equal to what? 4. Because they're telling you that X is measured in years. So then F of 4 is going to be equal to 5,000 times 1.0425 all raised to the 4th power. So let's type this in, 5,000 times 1.0425 raised to the 4th power. So in 4 years, this stock should be worth $5,905.74. When will my investment be worth $14,000? So what am I solving for in this particular formula? I'm going to be solving for what? X. So what am I going to set this whole entire function equal to? I'm going to set it equal to 14,000. So 14,000 is going to be equal to 5,000 times 1.0425 all raised to the X power. What's your first step? Before I do natural log, what can I do with that 5,000? Divide. So that's going to be 14 over 5 is equal to 1.0425 raised to the X. Now that I've got that base by itself, what am I going to do to both sides of the equation? I'm going to take the what? Natural log. So I'll have the natural log of 14/5 is equal to the natural log of 1.0425 raised to the X. What's next? What can I do with that X? I can pull it out of the exponent, correct? So when I pull it out of the exponent, that puts the X in the front. So I have natural log of 14/5 is equal to x times the natural log of 1.0425. Then what can you do, guys? Divide. To the natural log of 14/5 divided by the natural log of 1.0425. So I'm with 24.74 years. So any questions, guys, on these interest formulas? Again, there's two interest formulas. Again, it all goes back to which one you're going to use. It's based upon the compounding. All right? So you have the 10.5